Good morning, my YouTube viewers. It's Crystal here. I'm just here because I wanted to do a code review, and this is a modification of the code review that I did yesterday. And basically, what I'm going to do is yesterday we used the iterative imputer in sklearn, but today I'm just going to use regular Python code. And so with these two code reviews, you're going to learn two different ways to impute null values in a scenario where you loop through the rows and then you loop through the columns, because that was something that we had in a recent Kaggle competition question, which I wasn't really able to do. I had to borrow some code from somebody in order to be able to do it. And so I just thought to myself, well, this is silly. You need to learn how to use this. So what I did was I made my own data set, a very small data set, because what I wanted to do was I just wanted to learn how to do it, and so it wasn't necessary for me to have a really large data set in order to do it. So I've got my own small data set where I'm replicating what Kaggle did on a much smaller scale, and so I thought I would make a code review on this, because if I couldn't do it, then there's a big possibility that my viewers couldn't do it either. So we'll go over the code on this. So I created this program in Google Colab, which is a free online Jupyter notebook, and I do everything in Google, most everything in Google Colab and Kaggle, but sometimes I use Replit if I want to. What I'm going to do is, the thing about Google Colab, it doesn't have an adequate undo function. As you see, there's not even any arrows or anything like this, like a back and a forward arrow. But what you can do is, if you accidentally delete or write over code, which I have done in the past, you can go over here to all save changes, and it gives you a revision history, and then you can look on the revision history and possibly find the code that you deleted or marked over. And that's what I do whenever I accidentally write over code or accidentally delete it. And because as you can see, there's not even any undo function. If you go to editing, it says undo delete cell, but that's about it. It doesn't do anything else. So I just thought I'd show you a little trick that I do when you're using Colab and you accidentally write over code or delete it. So after I have created the Jupyter notebook, then what I'm going to do is I'm going to import my libraries. Now in this particular program, I didn't do any graphics because I had enough on my plate just looping through rows and columns. So what we did was we used pandas, which is a data frame library. It creates data frames and manipulates them. And then we used NumPy, which carries out numeric calculations, and it creates NumPy arrays. I think that's all we used in this particular instance. So just pandas and NumPy. We didn't do any graphics, so although I imported Matplotlib and Seaborn, I didn't actually use it. And then so what we're going to do, so this is something that was done just using pandas and NumPy. So what we're going to do is we're going to create the data set. And what I did was I created a very small data set that's just like some people I know, their ages, got some of the ages wrong, their place of birth, their vocation, and their relationship to me. And so if you'll notice, in every column, every feature except the name, I've got some missing values, because what we're going to do is we're going to loop through the rows and then the columns to get some missing values. And then so we created the data frame with df equals pd data frame data. And then we created another row called row column. And so you can see your row column here where we created the row. And value equals np a range len df. And then df, so you can see we've got the index, we've got the row column, we've got the name, age, birthplace, vocation, and relationship to me. Now what we're going to do is we're going to loop through the columns. And what I did was I used a lot of print commands to enable me to loop through the columns, but I just put a hash mark in front of the print commands that I didn't use. And the reason why is because you can see where I might want to use them again sometime. So, so the only thing I printed was row and column number and value of cell is, and then I printed null values is. So we created a blank list called null values. We created a blank list called rows, a blank list called calls, and then we created a blank data frame called locate. And then now we're doing a for loop. First thing we're going to do is we're going to iterate through all the rows in the data frame, and then after we have iterated through all the rows in the data frame, we're going to iterate through the columns in the data frame. So for row in range len df, for call in df. If PD is in a df lock row column, null values dot append df dot lock row column, rows append df row column row, calls append call, and then you print the row and column number is, and then you print the value of the cell, and then at the end of the for loop you print null values because you want to see what the null values are. So row and column number is 0, birthplace, value of the cell is NaN. So the value of the cells in all of these are NaN because that's what we want to find. We want to find all the null values. And then at the end of this piece of code, null values is NaN. It should read 8 times. So you should have 8 NaNs, and that's what we have. We have 8 NaNs because I put 8 null values in there. So now what we want to do is we want to prepare a submission frame, and the reason for that is because this problem that I created is based on a Kaggle problem, and so I wanted to put a submission frame in there as if we were going to submit it to Kaggle. So submission equals PD data frame null values. And you can see null values is up here. So we're making a blank data frame full of all the NaN values. Submission insert lock equals 0, column equals row call, value equals NP a range len submission. Submission columns equals row call value and submission. So now we've got the index here, the row call, and then the value, and all the values should be NaN, and we've got 8 NaNs. Now what we're going to do is we're going to impute the null values with mode, and the reason why I just decided to use regular code that I'm used to rather than using iterative imputer. So for call in df, if df call equals d type, if df call d type equals object, df fill na not listed in place equals true, and then for int it was going to be mode, and then for float it was going to be mean. So you can put, I just thought, well, rather than put mode, I just thought that's not going to be accurate. I thought it's best just to put not listed. So now you can see the DF, instead of all of the NPNANs, you have not listed on the string columns, and then on the age columns you have a mean. So on Catherine, you had the mean of 45.625, and on Keith, you had the mean of 45.65. Well, actually, Catherine's around 40, and Keith is around 56. So that wasn't an accurate reading, but it's just giving you the mean anyway, just telling you what the mean is. So now, after we have imputed the values, we're going to have to prepare the imputed values. So we have created a data frame called locate previously. See if I can find it. See, there's your locate where we had created the data frame. So locate rows equals rows, locate calls equals calls, because you notice in the previous data frame we had rows and calls. Okay, and so what you did was you take the list and you put the contents of the list into the data frame for the rows column and the calls column. And then we create a blank list called imputed value and a blank list called imputed rows. So now we're going to do another fourth loop. For I in range, then locate df rows equals rows I, df calls equals calls I. Imputed rows, append df lock df rows row call, imputed value dot append df lock df rows column df calls values. So imputed rows equals PD data frame imputed rows, imputed value equals PD data frame imputed value, because we wanted to convert the list to a data frame, and print imputed rows imputed value. So this is your imputed rows, this is your imputed value. So now what we're going to do is we're going to prepare our submission, because we wanted to do it as if it was in a Kaggle competition. Submission row num equals imputed rows. Submission value equals imputed value. Submission drop row call dot axis equals 1 in place equals true. Submission equals submission row num value. Submission to CSV equals submission CSV index equals false submission. So you can see that is what you would submit to Kaggle if you were going to have it scored. And then you come over here and okay, what we'll do is we'll run it. So we're running it, and in here it should actually give you a submission in a little bit, because you're going to have a submission here, and in a little bit, because it's Kaggle and because we've got a submission file, you should be getting a submission really soon. But it might take a while to get the submission, but you will, at some point, you will get a submission. And it will be over here. But it's just taking a while for it to come up. See, there you go. There's your submission. So you can see. And then now, what if you wanted to, like if you were doing analytics vidhaya, because analytics vidhaya doesn't have a Jupyter notebook, so you have to do the competition question in your own Jupyter notebook. And then in theory, you could download it, and then once you downloaded it, you could upload it to Analytics Vidhya if you wanted. But I don't really use Analytics Vidhya that much anymore, but I just mainly use Kaggle. But one of the downfalls of Kaggle is if you want to enter a competition and you win, you've got to go to America to get the prize. So that's it. That's it for what we've done. So this is just a modification of what we did yesterday, and I think it's a little bit easier to work with. But what we did yesterday obviously is more accurate. But this one is if you've got text files, if you've got text columns, object columns, then you can use this code here if you don't want to have to ordinal encode the columns. Then you'll have everything in place as it is. So this is a good one if you've got string features. The iterative imputer, it only imputes numeric values, but this code that I've got here, it will impute strings. So I'm going to go ahead and close this video because I think I've covered all of the important topics. And if you like my video, please like, subscribe, and share. And I would like to thank all of my subscribers for subscribing to my channel. It helps give me the impetuous to keep making videos and then putting them on YouTube. So thank you so much for watching this video, and I will be making some more videos for you soon in due course.